Hello and welcome to the Slingshot channel. You know these knives that you can buy for under 5 euros on Temu. These are knives that have actually, like one knife's handle is the other knife's sheath. So they just stick in each other and then you can pull them apart, and they're actually quite nice. But the problem is the blades are really short. I don't like it. It's not pleasing at all if the handle is longer than the blade. So I love the concept, but I want a longer blade. How is that possible? Well, let me show you what I came up with, or what Martin Koning came up with, and I refined together with him. Based on Martin's idea, I made this little mock-up, and if you see what happens is, you have these things that are actually knife handles, and if I pull them out, then the wooden blades appear like magic, and as you see, they're much longer than the collapsed knife, and I can always, put them together again, like so, and they disappear. Magic? No, technology. So what Martin's idea was is basically to make these blades also sliding back into their own handle, so that the handle is actually hollow and they snip back, and I can actually simulate this for you by sliding in this thing. So this is how far it retracts, and now it has like the length that the Temu knives have. Very unpleasing, but you can pull it out and then it snaps shut like a lock, and then it's a fixed blade knife. So again, the entire functionality is inside. So these are liner locks, actually modified liner locks that keep the blades out and lock them. But they are based on a rocker that I invented. Well, it's not a super big invention. And the other blade will press on the other side of the rocker lock and unlock it. So when I push them together, automatically each blade unlocks the other blade. So this means that without like a tool, you cannot push this back. These are fixed knives now, or locked knives now. So Martin and I, we thought about what kind of product could be made from this. And actually we had the idea to use like a tanto knife, where that happens like in both ways. And it's a slightly curved tanto blade. And as you see, this is the next mock-up that I came up with. Still made from wood and with blades made from aluminum. The double tanto. Let me show you their features. So as you see, they're still not real knives. They look more like real knives, but they aren't, because the blades is made from aluminum. Now as you see, these knives actually are shorter, and also the blade is much wider, and that is because the fuller really here is used to stop the blades also from sliding out of the handles. So it's actually the fuller that is also a guide rail for the knife. And this makes a lot of sense, because a tanto knife should have a fuller. But other than that, it's still the same functionality like the first mock-up. So if I put this together, then they slide in place, like so. So the first mock-up really had no fuller, so actually the blade is thicker in the end, and that keeps it from not slipping out. But it also means that the blade has to be ridiculously narrow. So these are really narrow blades, and still functionality is very cool. But of course it's not a pleasing design. I also saved space where I could, so this is actually shorter than the first mock-up. Every square millimeter of room is used in here. So the walls of the wooden frame is really narrow, so that it's already a little bit fragile. As you see, the blade length is absolutely the same. It's 22.5 centimeters. And the overall length, of course, for the first mock-up is longer, because there is more reserve in the handle. So I really used up every little inch. And of course this is a much more pleasing shape, I think. So maybe you noticed that when I pull out the blades, there's actually two stages. There's this stage, at what point it's actually stopping the sliding motion. And this is now, the blades are now pulled out. And now if I pull them out, I pull the rest of the blades out. So this is because the tips of the blade are actually held back like here, so that it cannot happen that they slip out halfway and then in the end of the motion are not forced to go into the lock. That would then mean that one of the blades wouldn't fully lock, but it would just be loose and only halfway out, and we can't have that. Therefore we hold this back, so when you slide it in, the tips are still held firmly inside of the other one. And now I have to pull a little bit harder to overcome the ball detention that I installed at the end of this. So then, only then, it slips out and they go into full locking mode. I think I will give it to Dirk Hofmeister at the upcoming IWA show, because I think this needs to be made into a product. Don't you agree? It's just too sexy not to do that. Now, of course, people will ask me, when will it come out and how much will it cost? We don't know. It's definitely not a 2024 product. We're completely full with our planning. We got so many new knives coming out. The Hirschfänger, the fillet knife, all these things will come out this year. For next year, this can still be made. It won't be cheap because the mechanism is actually quite finicky and it needs absolute precision in the manufacturing. So we can only go to the top-notch knife manufacturers, not to the cheapo guys. So this, and it's actually two knives that, you know, it's not one knife. It's actually, you have to make two knives for the set. So it won't be cheap and it will definitely be a limited edition. But I think it will also be very, very cool. Now again, why the 10-toe blade and why the curved form? Because I think it's kind of natural, you know, you just have to, if you open this with your outstretched arms, you form like a little bit of a curve anyway. So we think that this is actually very elegantly picking up on the natural motion of your arms when you pull things apart, like so. Next, Martin will actually try to make a 3D printed one from his design idea. He has a different idea for the locking mechanism. It is more like a little bit like the Böker Slike, if you know that knife. And he will make a mock-up in 3D printed. And I think that will also be most interesting if you compare my way of prototyping and his way of prototyping. It's actually a very inspiring cooperation that I have with Martin. I really like it. And I hope you do too, because that's it for today. Thanks. Bye-bye. It's a wooden mock-up, guys. It's a wooden mock-up. Of course, it's not solid. I have to disassemble it and see what went wrong. Okay, this is how it looks under the hood. So this is one part, this is the middle part, and this is the white part of the handle. And you can see that there is this little nail that actually stops the blade from moving forward too much, so it slides out of the handle. And what happened is that we have a little crack that formed in here. So you can see the crack here, I think. And this crack actually allowed the blade to slip out, so we have to glue this together. And you see how thin the wood is at places. I really try to save it. If this is made from steel, there will be no such issues, but wood is wood. And by the way, this is how the rocker lock works. You can see this lock actually slips here. This edge here slips behind the blade, so it holds the blade. Let me show you. So if the blade is in here, kind of hard to do this with one hand, and it slides forward until it hits the nail. And then this here, this is spring loaded, as you can see. There's a spring underneath. This here slips behind the blade, locking it in place, much like a frame lock, just only sideways and not from above. And so if the other blade comes in, it automatically activates, because the other blade, of course, slips in this part of the handle. So if it comes in, it will actually automatically press on the rocker lock, unlocking the other blade. And this here is the ball retention. I can also show you how that works. So if you have the blade, you can see that I have this little, depression in here. So this here actually locks into the other blade, so that it's held back by the pressure of the wood, because this is actually a wooden spring. As you see, I used the frame itself to form like a spring by cutting a groove in here. And so this slides into this here, holding it under pressure, but making it possible to overcome it if you pull a little bit harder, making sure that that part of the blade comes out last. So this is how it looks under the hood. Hope you understand it.